The deepest and coldest of the Great Lakes, Lake Superior, was once thought to be immune from algae blooms. Today, it is one of the fastest warming lakes in the world, and toxic algae blooms are a looming threat to the ecosystem and drinking water. Now, scientists are trying to understand why this is happening, what's at stake, and what, if anything, can be done to stop it. This report was made possible in part by the Fund for Environmental Journalism of the Society of Environmental Journalists.
On a recent hot, still July day, Northland College researcher Rhianne Loisel steered a flat-bottomed boat into Chequamegon Bay on Lake Superior, off the shore from Ashland, Wisconsin. Her destination? CB1, a spot a quarter mile or so offshore in 17 feet of water. It's one of 31 sites along Wisconsin's Lake Superior shoreline where a team of researchers is sampling on 6 different days throughout the summer. Loisel drops a tool called a water quality sonde into the lake. It gathers data every 2 seconds as she lowers it down through the water on a steel cable.
So we'll get this snapshot in time of what's going on with the nearshore areas of the lake.
Matt Hudson is Associate Director of the Mary Griggs Burke Center for Freshwater Innovation at Northland College. He's leading one of the groups of researchers sampling this stretch of the lake this summer.
There's sensors in there that tell us basically the amount of algae in the water, both green algae and then blue-green algae. And then we're also looking at things like temperature and conductivity. We lower this into the water from the surface to the bottom. We call it a water quality profile, and we do that at each one of our sites.
Researchers are also collecting water quality samples to analyze for everything from the tiny microbes that live in the water to nutrients like phosphorus that the algae needs to grow. Hudson says all this data will help scientists piece together the story of how an algae bloom evolves in Lake Superior.
If we analyze for the kinds of things that would tell us, okay, where are the algal cells? Where are they? Are they in the water column? What's the temperature? What's the nutrients? What are all these different pieces to the puzzle?
10 years ago, this kind of research would have been unheard of. But then in 2012, researchers confirmed the first ever blue-green algae bloom in notoriously frigid Lake Superior. It followed a massive rainstorm that dumped up to 10 inches of rain over Duluth. Then in 2018, another huge storm caused major flooding, this time over northwestern Wisconsin. Soon after, a blue-green algae bloom stretched for parts of 50 miles along the south shore of Lake Superior, from Superior, Wisconsin, all the way to the Apostle Islands National Lakeshore, including here at Myers Beach, a popular departure point for kayak trips. The bloom looked like green paint floating on the surface of the water. Brenda LaFrancois is an aquatic ecologist with the National Park Service.
They can look a lot of different ways, but one of the things that we look for is kind of a bright green surface film.
The algae is unsightly. It often stinks. It can harm tourism economies around the lakes, and it can impact water quality. The city of Ashland pulls its drinking water from Lake Superior.
And then one of the big concerns, obviously, is their potential to produce toxins. They can produce really potent neurotoxins and other kinds of toxins, and those can affect, our pets, wildlife, and human health as well.
So far, researchers have not found evidence of toxicity in any of the blooms on Lake Superior, but they stress that doesn't mean that's not a possibility in the future. And while scientists are still trying to figure out exactly what's causing the algae to grow in such a clean and cold lake, they believe there's a strong link between the growing number of blooms on Lake Superior and climate change. Blue-green algae needs nutrients to grow, especially phosphorus, which gets washed from the land into the lake during big storms, like those in 2012 and 2018.
We know that those blooms did occur in years that had pretty catastrophic flooding in the region, 500 to 1,000-year precipitation events and flooding from the tributaries.
And those big storms are predicted to occur even more frequently because of global warming. LaFrancois says there's also a second climate change link.
We also know that those blooms tended to happen in years that had warm springs and early summers. So years where the lake kind of started warming up early and continued on that trajectory to have warm summer water temps, not unlike what we're seeing out here today.
And Lake Superior, it turns out, is one of the fastest warming large lakes in the world. Summer surface water temperatures in the lake have increased by 5 degrees over the past 30 years. But scientists are still working to better understand the precise mix of factors that determine when and where blooms on the lake will form. And an important part of that equation is likely the many streams that feed into Lake Superior.
Yeah, right now we're at the mouth of Fish Creek, or Fish Creek Slough, just on the west side of Ashland. And so this is one of the many fabulous coastal wetland areas that we have in this region of Lake Superior.
Fish Creek is the main tributary into Chequamegon Bay near Ashland, Wisconsin. This is a place that has flummoxed researchers like Hudson. As one of the warmest and shallowest parts of Lake Superior, it's seemingly an ideal place for algae blooms to form. But so far, they haven't found any here.
The reason we're here is this is going to be one of the places where we're going to look for clues as to the puzzle of why we haven't seen blue-green algae blooms in Chequamegon Bay yet.
One possibility is there aren't the same species of algae cells along the lake shore surrounding Chequamegon Bay. Another hypothesis is that so much sand and clay washes into Chequamegon Bay during big rainstorms that the algae cells get buried and not enough sunlight filters down into the water for the algae to grow. So this summer, researchers are also collecting samples from Fish Creek and a number of other streams that flow into Lake Superior. That water gets analyzed here at the Large Lakes Observatory at the University of Minnesota Duluth. Researchers are also taking algae cells they collect from different places to see if they can grow blue-green algae in the lab. Scientists are trying to pinpoint the places on the landscape where the algae cells or the nutrients are coming from that feed the blooms that are forming in the lake. If they can do that, then maybe they can help land managers identify the places they need to prevent phosphorus runoff or control erosion into the lake, and maybe stop blooms from growing in the lake in the first place. Bob Sterner directs the Large Lakes Observatory at the University of Minnesota Duluth.
So what we're trying to do is get a much better handle on where are those control points, if they exist, that may be more important than others, so that we can focus our conservation efforts where they'll do the most good. Even though we're still talking about a minor part of the volume of the lake, if people get in their heads that this is a place that sometimes turns really green, that isn't a real pivot from the mental space that people normally have about Lake Superior.
At Great Lakes Now, we aim to cover the Great Lakes region and the people who live here, like you. Please follow us on social media, subscribe to our YouTube channel, and sign up for our newsletter at greatlakesnow.org.